In this chapter, we're going to define trigonometric functions. Let us look at this right triangle. Let us name the sides of the triangle. Here we have the hypotenuse C, and then with respect to this angle theta, this is the opposite B, and this here is the adjacent A. So this cathetus is opposite to the angle theta, while this one is adjacent to it. So that's why we call these one the opposite and this one the adjacent. We start with the ratio B divided by C, opposite divided by hypotenuse, which is defined as sine of theta, German sinus. So when I have the angle theta, then sine of theta is the ratio opposite divided by hypotenuse, and because any right angle triangle with this angle theta here given has the same ratio B divided by C due to similarity, for example at this triangle or at this triangle, so this ratio is just a function of theta. The second ratio we're interested in is the one between adjacent A and hypotenuse C. And this is called the cosine of theta, in German cosinus. The third and last ratio we're interested in is the opposite B divided by the adjacent A. This ratio is called the tangent of theta, or in German tangens. There is a fourth ratio I want to mention for completeness reasons, adjacent A divided by opposite B, which is called the cotangent of theta, or in German cotangens, but we're not going to use it. Knowing the trigonometric functions and having a calculator at hand, we can now calculate the length of a side in a right triangle where we're given one side and one angle. So we do not have to construct the triangle to find this length. Let us look at that in the next few examples. Let's start with example 1, where we're given the side C, the hypotenuse, and the angle alpha, and we're looking for the length of the side A. C is the hypotenuse, A is the opposite, so opposite and hypotenuse appear in the ratio of the sine. So we use the trigonometric function sine of alpha, which is opposite A, divided by hypotenuse C. By inserting the values for C and alpha, we get sine of 37 degrees equals A divided by 7.8. Now let us use the calculator to find the value of sine of 37 degrees. So sine 37 and enter, and we get the value 0.602. So we get 0.602 is A divided by 7.8. Let's solve that for A by multiplying with 7.8 and switching the sides. And we find that the side A is approximately 4.7 centimeters long. Note that I have not used the brackets for the sine of alpha or sine of 37 degrees. We don't have to use them here when it's clear to what the sine of refers to. And since we mathematicians like to write as little as possible, we typically don't use them. Now, to be honest, it's not only for being lazy, but also if there are too many brackets, the whole thing becomes very difficult to read. In example 2, the side A is given and the angle beta, and we're looking for the side B. This here should say B. With respect to the angle beta, the A is the adjacent and B is the opposite, so the trigonometric ratio where adjacent and opposite occur is the tangent. So we have to look at the tangent of beta, which is B divided by A. Let us solve that first for B before inserting the values, so we have to multiply by A, and we get A times tangent of beta is B. Then let's switch sides, we get B is equal to A times tangent of beta. Let's insert the values now. 9.1 times tangent of 51, and we get approximately 11.2 millimeters. Please note that when multiplying here with A, I have written A times tangent of beta. I could have also written tangent of beta times A. I do this on purpose because when you want to calculate this here and you insert the numbers, if you write tangent of beta 1 times 9.1, you have to be very careful that when you enter it in the calculator that you calculate only tangent of 51 and then the result you multiply it by 9.1. So to avoid that problem, it's just simpler to always write the 9.1 times the tangent of 51. What I mean is that if you do it the wrong way, like shown here, so you don't close the brackets after the 51, you'll get a completely wrong result. In example 3, the sides B and the angle alpha are given and we're looking for the side C. B is with respect to alpha, the adjacent, C is the hypotenuse, so the corresponding trigonometric ratio is cosine. And we get cosine of alpha is B divided by C. Let us solve this for C, so let's multiply with C first. So we get C times cosine of alpha is B. Now remember, cosine of alpha is just a number, so we divide by this number, we divide by cosine of alpha, and we get that C is B divided by cosine of alpha. Let's insert the values. And we get 5.2 divided by cosine of 28 degrees, and the final value is approximately 5.9 meters. In example 4, the lengths of the opposite of alpha and the adjacent of alpha are given, namely 2 and 3, and using Pythagoras we can very quickly calculate the length of the hypotenuse, which is square root of 13. Try now on your own to find the sine of alpha, the cosine of alpha, and the tangent of alpha. Stop the film now, and now I show you the results. Note that from here I have expanded by square root of 13 to get rid of the square root in the denominator. There is an English mnemonic how to remember these three ratios. So sine of theta, opposite hypotenuse, cosine here, adjacent hypotenuse, tangent opposite adjacent, and the way to remember it is some officers have curly auburn hair to offer attraction. In German there's also a mnemonic. You have to know that in German the opposite is called die Gegenkathete and the adjacent is called die Ankathete. So sine of an angle is G divided by H, cosine of theta is then A divided by H, G divided by A and A divided by G for the cotangent of theta. When we write now the four ratios or four functions next to one another, so sine, cosine, tangent, cotangent, we write it all on one fraction, so we get this expression here and we can remember that as Gaga Hühnerhof AG. Well, I don't know if some of these mnemonics are of help to you. You can use them for sure in the beginning to remember these ratios. However, I expect you to know them very soon by heart, especially during this chapter.